you present you grade 8 mathematics starting from the beginning, which is unit 1 talks about squares, square roots, cube and cube roots. This is for part 1. To start, what is a square number means? Let me define what the square number means. When the process of multiplying a rational number by itself, okay, consider the rational number, and multiplying it by itself is called what? The squaring the number. For example, some of the few square numbers are, let's say this is 1 times 1. You see, the number 1 multiplied with 1 and gives what? 1, and 1 is the first square number. 2 times 2 is 4, because you see, the consider 2 as rational number and multiply by itself, it is 4, and 4 is the second square number. 3 times 3 is equal to 9, and it is the third square number. It goes like this. So when you say the first, the second, and the third, we have to start from the number 1, because we are counting the numbers, and the counting numbers are said to be what? Natural numbers starting from 1. So 0 cannot be the first square number, okay, in this case, because the number 0 is not belongs to the set of natural numbers. So some other square numbers are like 0 meaning 0 times 0, 0.04, which is 0.2 times 0.2, 25 over 16 as a fraction, which is 5 over 4 times 5 over 4, and 100, 10 times 10, and we continue just like this. So these are known as the square numbers. Don't forget that squaring a number means multiplying itself, the number by itself 2 times, okay, 2 times, or multiplying the number by itself is called squaring the number. If the number to be multiplied by itself is b, see, the number that we are going to multiply by itself is b, then the product b times b, okay, b times b is usually written as b square. See, written as what? B square, and it can be read as b square, or the square of b, or b raised to power 2, or you can say that b to the power of 2. You can state either of the 4 statements in order to say b the power of 2. You can say that, okay. This is how can we read the square of a number. So in number here on the screen you are seeing 81 is equal to 9 square. So the number, to see the number, this one is 81, the standard form of the number, and the number 9 square is the power form, okay. It is what it's called the power form. It says what? The power form. And the number 9 is called what? The base, meaning the number that we are going to multiply itself, okay. And the number 2, this number 2 refers to what? The exponent, or the power, you call it the power, and this power or this exponent refers to how many times we have to multiply the base. In this case it is 2, yes, so we have to multiply 9 times 9, meaning 2 times. So these are statements that you can express like a number is a standard form and a power form, and a standard form and a power form. For example, here is the example that we are going to find out the square of a 7, b 11, c 23, d -4, and e 0.43. So these numbers are all the numbers in different categories. The first and the second one is a natural number, 23 also natural number, this is a negative integer, this is a decimal. You can add a fraction by your own or yourself to solve this or to see the solutions. The square of 7 means 7 times 7, which is 49. The square of 11 means 11 times 11, 11 times 11, which is 121. 23 times 23 is the square of 23 again, so it is equivalent with 529. And the square of negative 4 is can be multiplied just like this, because there is a negative sign in order to distinguish it from the plus or minus. Negative 4 times negative 4 is equal to 16. Negative 4 times negative 4 is equal to 16. You have to remind over here is a negative number multiplied by a negative number is positive, always. A negative number multiplied by a negative number is positive, so that is why negative 4 times negative 4 is 16. So the last one, 0.3 times 0.3 is the square of 0.3, which is equivalent to 0.09. In this case, the digits the digit after a decimal point in the case of product is 2, because when you count in individually the number of digits in the multiplicand, there are 1 and here is it 2, so the digits after we multiply or on the result must be what? Equivalent to the sum of the number of digits in each multiplicand, that is 0 and 9, which is 2. So when you multiply decimal numbers, you have to count the digits after a decimal point in both cases, and finally you have to put all the sum of the number of digits in multiplicand or in the product. Notation here is it very important notation. Some students work like a square is means a plus a, or sometimes they make it 2 times a, but it is quite different. Okay, it does not mean a plus a or a 2 times a. It is a square means a times a. So a square and 2a are very different numbers. Maybe there is only one number that satisfies a square is equal to 2a, that is if the value of a is 2. In other cases they will never be what? Equivalent. They are not be equivalent. So a square means a times a, not 2 times a, or not a plus a. So we have to remember that a square means a times a. Okay, here is another definition that is important for perfect square numbers. A rational number is called a perfect square. A perfect square then if and only if x is equal to n square. If when you say the value or x is said to be a perfect square, there should be another number that gives multiplied by itself gives what? The number itself, that is x. So x is equal to n square for some rational number n. This means n is element of rational number. N is element of rational number, meaning all the n's are belongs to q. So when you say the number x is said to be what? A perfect square number, there should be a rational number that gives what? Multiplied by itself to get what? The given number. So a perfect square number or a perfect square is a number that is it is square roots. Okay, when we take out from the square roots, it is the square root is a rational number. For example, 4, 1, 0, 9, just such kind of numbers are said to be what? A perfect square numbers, because we can get them by taking the square roots as a rational number. Example of perfect square numbers are like this: 0, because 0 times 0 is 0, 1, which is 1 times 1, you see, 4, which is 2 times 2, 9, 3 times 3, 16, 4 times 4, 25, 5 times 5, 0.0025, which means 0.05 multiplied by 0.05, 1 over 100, because 1 over 10 times 1 over 10 is 1 over 100, 64 over 169, which is 8 over 13 times 8 over 13. Just it continues just like this. You can mention different kind of perfect square numbers, but the numbers like 2, 3, 5, 6, 7, these are not a perfect square numbers, because there is no any rational number that gives the square of the number gives what? This kind of numbers. For example, over here, find x square in each of the following numbers. X is equal to 4 over 5. You see, if x is 4 over 5, to find out x square, just multiply, make it what? 4 over 5 the whole square, meaning 4 over 5 times 4 over 5 is equal to 16 over 25. B, x is equal to negative 50 over 3, the negative fraction. To find x square, just multiply negative 50 over 3 by negative 50 over 3, which is 2500 over 9. Don't forget that negative times negative is positive. C, x is equal to negative 0.02 as a decimal of negative numbers. To find x square, just multiply this number by itself. So negative 0.02 is multiplied by negative 0.02, which is equivalent to 0.0004. Don't forget that the number of digits after a decimal point, when we multiply decimals, it must be the sum of, or which is equivalent to the number of digits in both multiplicands, both number that we are going to multiply. Okay, there is a very important notation over here. Notations: the square of a natural number is also a natural number, meaning in this case, the square of a natural number. Take any natural number and square it. The answer is always a natural number. The same thing for whole numbers. When you multiply a whole number by itself, the answer is also existed in a whole number. But there may be special cases in negative integers. When we multiply a negative integer by a negative integer, or when we square a negative integer, the answer is always positive. This is so the square of a negative integer is not a negative integer. So it is the square of a negative integer is not closed under squaring the numbers. There is no any meaning for 0 to the power of 0, meaning 0 to the power of 0 is meaningless, just like dividing a number by 0, dividing the number by 0. So they are similar with meaningless. And if a is any rational number and a is different from 0, you see, a is different from 0, then a to the power of 0 is equal to 1. This is a very important notation to prove that you can make it 100 over 100, you see. And you can see that the rule of the exponents, when you divide the same bases with the same exponent, you can prove it by yourself. Solution of some questions of exercise A, which are existed on your textbook. The questions start until question number 6 seems to be very simple, and to show the question number 7a, so to find the a's square number, just select the number which is refers to as 8 and square it, okay, which is 8 times 8, and this is 64. So the a's square number is 64. The a's square number, the first one is 1, the second one is 4, the third one is 9, the fourth one is 16. Just go like this, and the number a's square number, perfect square number, is 64. You can find out the tens perfect square number by your own. That is becomes 100. And question number 9, let the first square number, we are going to prove that the difference of the two consecutive square numbers is always an odd number, says the question. Okay, to show that let the first square number is n square, and its consecutive square number is n plus 1. If the first number is n and its consecutive is always n plus 1, is n plus 1. If the first number is x, for example, consider the number 2 and 3. So the number 2 and the difference between 2 and 3 is 1, is so 2 and 3 are consecutive numbers. Consecutive means, by the way, the number system that there is no any gap, or we can say that's integers, there is no any other integer between them. Or their difference is always 1. So if n is the first number, and then n plus 1 is the second one, so we are going to find out what the square of there's two consecutive integer numbers. So if n is the first number, the n is square is n square, and its consecutive becomes what? N plus 1 the whole square. So we have to square this one. Don't forget that when we n plus 1 the whole square means does not mean that n square plus 1 square. So in this case you have to make it that n plus 1 times n plus 1, just like this. N plus 1 times n plus 1. So n plus 1 the whole square is refers to what? N square plus n plus 1. This is the square of n plus 1, and there is the number itself n square, so the difference minus n square is equal to this number and this one are like terms because they have the same variable with the same exponent. So we can subtract n square minus n square is 0, so it can be simplified that to n plus 1, to n plus 1, and to n plus 1 is always an odd number when n is any natural number or any integer. You can take it any integer to n plus 1 is always an odd number, so to times n is even, and to n plus 1 is an odd number. So we have finally we proved it. Yes, we proved it. Okay, this the next one is about existence theorem. The existence theorem means there exists a number for each rational number. For example, let's say for each rational number x, there is a rational number y. Okay, for any rational number x, there is another rational number y. The value of y should be greater than or equal to 0, because when x square is or when we square the number, its value is always positive or 0. So for each real rational number, for each rational number x, there is a rational number y such that x square is equal to y. Whenever you take any value of x or any rational number x, there is a rational number y such that x square is equal to y. X square is equal to y. This means every rational number has its own square numbers. You see, every rational number has the square rational numbers, which means take any rational number, square it, and the final answer is also what? A rational number. Okay, after we come completing the existence theorem, let me see what is a rough calculation means and when we use the rough calculations. Sometimes the measurements, especially in measuring length, distance, mass, time, just like this, it may be what not accurate, so we have to take the rough calculations. So in rough calculations it needs to be what approximations, and in approximation there is a rule such that the number which is more than half of the given number is approximated to the upper one, and the number which is below to the half of the number is rounded to 0. For example, to round the number to the nearest tens means that half of 10 is 5, and 5 and the number which are greater than 5 are rounded to 10, whereas including 4, 3, 2, such kind of numbers are rounded to 0. So rough calculations are very important in calculations, because sometimes the rough calculations you have to use big numbers, especially in decimals, and when we multiply we have to count all the digits after the decimal point, then that is time taking and taking spaces. So it is better to write or find out the approximation value of the numbers. For example, find the approximate value of x square in each of the following. The approximate value. Approximation means, don't forget that approximation means putting the number to the nearest values. So for example, x square, to find x square, assume x is equal to 4.8, and it can be rounded to what? 5, because the digit after a decimal point is 8, and which is above the tens place, or half of the 10, so it can be rounded to what? 5. Then x square can be rounded to what? Is equal to what? 5 square, which is 25. You see, you can prove it by your own by using a calculator. 4.8 times 4.8 is needed to us 25. You can find out. And b, if x is 0.043, see 0.043. In this case, you see, after we multiply the number of digits after a decimal point should be what? 6, because 1, 2, 3 have to multiply by twice, so it becomes 6. In this case, it is bulky, or it is time taking as well as space occupying. So 0.043 can be rounded to 0.04. It's possible because the last digit is 3. Yes, the last digit is 3, and it's rounded to the lower one, that is 0. So it can be 0.04, and this square becomes what? 0.0016. 0016. And on your textbook there is methodology to find out the square of decimals. In at the end of the textbooks, you can refer or you can read by your own. Okay, let's move to the square root of rational numbers. Previously we have seen the square of the numbers, okay, meaning multiplying the number by itself. Okay, in this context, in this topic, we are going to taking the square root of the number that we have multiplied before, meaning extracting the square roots. Okay, extracting the square roots. So the definition, when you see the definition, for any two rational numbers a and b, see, for any two rational numbers a and b, if you see, if a square is equal to b, then a is called the square root of b. You see, a is equal to what? The square root of b, which is vice versa with the square of the numbers. B is the square of a, and a is equal to what? The square root of b. This is the vice versa statement of a square is equal to b. So a square is equal to b means b is equal to the square root of b. A. So for example, 5 is the square root of 25. See, 5 is the square root of 25, which means 5 times 5 is 25. 5 square is equal to 25, and 5 is the square root of 25. You can see that. 0.02 is the square root of 0.0004, since 0.02 square is 0.004. See, 0.0004. So this is how can we take out square roots from radicals. In there is a notation over here. The operation extracting square root is the inverse of operation squaring. Okay? Squaring and extracting square roots are opposite, like multiplication and division are opposite operations. Addition and subtraction are opposite. Yes, extracting square root is the opposite of squaring the numbers. So the symbol for the square root is this radical, and it's called what? Radical sign. It is called what? The radical sign. For b, for any rational number b greater than 0, greater than or equal to 0, see, greater than or equal to 0, the expression radical b is read as radical b. It can be read as what? Radical b. Radical, this is the radical, and this is b. Don't forget that the value of b must be okay, it must be greater than or equal to 0. If the value of b is negative, the statement becomes what? Disqualified, because there is no any number that gives a negative after we multiply by what? Itself. For example, negative 4 times negative 4 is positive 16. It's not negative. So the value of b should be either 0 or positive. It must be what? Positive. And the number b is called radicand. It is called what? Radicand. The number b is called radicand. Okay, for example, here is it. Let's find the square root of x. Find the square root of x, where x is 100, meaning finding the number that multiply by itself gives what? 100, which means radical 100. You see, radical, this is radical 100, which is equivalent to 10, because 10 times 10 is 100, right? B, x is equal to 169. X is equal to 169. See, to find this one, we have to find out the number that multiplied by itself gives 169, and it can be written as the square root of 169, and which is 13, which is what? 13. C, x is equal to 1 over 121. This is a fraction. This is also a perfect square number. 1 over 121, meaning you have to find out the square root of 1 and do the square root of 121 at the same time. So it gives what? 1 over 11. You see, 1 over 11 times 1 over 11 is 1 over 121. Okay, notation. This is very important notation. Negative 4 times negative 4 is, which is negative 4 square, which is 16. Yes, 16, but the square root of 16 is 4. The square root of 16 is what? 4. Yes. Note negative 4. Don't take the square root of 16 is a negative 4. In order to get the negative 4, see, in order to get the negative 4, we have to, as a square root of the answer, it should be written as in the form of negative of the radical 16. The negative of radical 16, which is negative 4. So the reason why we are not going to radical 16 is equal to negative 4. You see, this means radical 16 is equal to 4. It's obvious, right? Yes. And the radical 16 is actually, it's possible to say negative 4, but can we say that this means negative 16 is equal to 4 means, and negative 16 also is equal to negative 4 means, by transitive rule, you can see that 4 is equivalent to negative 4. Is that possible? Is that possible to say 4 is equivalent to negative 4? It's not. It's not. This is the reason why with the square root of 16 is only 4. Only 4, and this to get the negative 4, we have to make the negative square root of 16. The negative square root of 16. So sometimes you call it, this is the principal square root of 16, and the principal square root of 16 is 4. The principal square root of 16 is what? 4, not negative 4. Okay, let me continue.